Algebra 2, state sample questions. Number 1. What is the solution set of the equation 3x plus 25 divided by x plus 7 minus 5 equals 3 divided by x? So this is the method I like to call of multiplying out the denominators. See, nobody really likes to work with fractions. I mean, students say it all the time, but honestly, teachers don't really like them either. Regular numbers are nicer, and regular equations without fractions are just, a little bit friendlier. So what we want to do here is we want to get rid of fractions. I want to figure out a way to rewrite this equation so that there's no longer any fractions. And what that means is I got to get rid of the denominators. So this x plus 7 that's down here, what I can do, how I can get rid of it, is I can multiply it out. Now, only 3x plus 25 is being divided by x plus 7, but I can multiply all three of these, pieces of the equation, every term in the equation, I can multiply that by x plus 7. Because to keep an equation balanced, when you can't just multiply one piece of an equation, you always have to multiply everything across the board. All right, so that's what we're going to do here. Let me zoom in a little bit so we can get a better view here. And so I'm going to multiply everything by x plus 7. I'm going to multiply the first piece here, and let me write this out. So 3x plus 25 over x plus 7, and I'm going to multiply that by x plus 7. Then I have a minus 5. I'm going to multiply that by x plus 7. Then I have a 3 over x equals 3 over x. I'm going to multiply that by x plus 7. Now, the one term that has the x plus 7 as a fraction denominator, when you multiply that by the x plus 7, you don't actually need to do much. It just eliminates the denominator there for you, so you don't have to do any distribution to that specific fraction. So that's just going to be 3x plus 25. But the other pieces, you do need to do the multiplication out, and that's going to require a little bit of distribution. So I got to distribute negative 5 here, negative 5 here, so that's going to give me negative 5x and a minus 35 equals 3 times x plus 7. Now, one thing I want to point out here is, can I cross out these x's? The answer is no, we cannot, because this is x plus 7. They are connected through addition. And the reason why we could cross things out is through division. So like this is being multiplied by x plus 7, and it's being divided by x plus 7. Multiplication and division are inverse operations, so they could cancel each other out. Addition and division are not. So you can't cross out the x and the x plus 7 here, so we have to distribute just like we did here. And I'm going to end up with a 3x plus 21 over x. And now I'm down to one denominator. So now I need to do exactly what I did here. This denominator of x, I'm going to multiply every term by x. So I'm going to multiply this by x. I'm going to multiply this one by x. I'm going to multiply this by x. And I'm going to multiply this whole thing, or individually, by x, either way. And so that's going to give me 3x squared plus 25x minus 5x squared minus 35x. And then remember this one over here, because this is the one problem that has the x that I'm trying to get rid of, that's just going to cancel out, and that one doesn't require any distribution. So this is 3x plus 21. All right, so isn't that much better? Now there's no more fractions. But now we need to still do the algebra here. And so the first thing we want to do is combine all of our like terms and see what we're looking at. So I have a 3x squared and negative 5x squared. That's negative 2x squared. I have a 25x and negative 35x over here. That's a negative 10x. And that's equal to 3x plus 21. And this is going to require some factoring, so I want to set it equal to 0. So I'm going to minus my 3x over. I'm going to minus my 21 over, and that's going to give us a negative 2x squared, and negative 10x minus 3x, to get that over here, is going to be negative 13x, and we're minusing 21 from nothing, so it's just minus 21 on the end, moving that, setting it equal to 0. Now I can factor that as is, but I personally do not like when my first number is negative, so I'm going to change the sign. But I can change the sign by changing every sign. So one thing is anytime you want, you could always change the sign of everything. And basically that's just dividing everything by -1 or multiplying everything by -1. Either way, I'm going to get positive 2x squared plus 13x plus 21 equals 0. That's going to be a little bit nicer to play with. So now we need to factor that. And, we're trying to solve for x. And we're going to get a couple answers here. Factoring this is going to require some AC, factor by grouping, as we call it. And this is something that students struggle with sometimes. It's just basic factoring. And this is considered basic factoring. So the way to do AC, now first of all, I want to check to see if I have a GCF, a common factor between 2, 13, and 21. No, there's not. So that's how I know I need to do AC, because there's a number in front of x squared and it's not a GCF. So AC factoring works out that I want to figure out what A times C is. That's the first number times the third number. That multiplies to 42. Then I split my middle term into two numbers that multiply to AC, but add to the term I'm splitting B. So what are the numbers that multiply to 42 and add to 13? And so you think about factors of 42. Well, it's 42 and 1, 21 and 2, so on, so on, and so on. 6 and 7. 6 times 7 is 42, and 6 plus 7 is 13. So I bring down the first term, 2x squared. And I'm going to bring down the last one, plus 21. But the middle term is going to split to two numbers. It's going to split to 6x and 7x, because they combine to be 13x. And technically, they multiply to 42x squared, which is what this whole term times this whole term is. But it is going to split to two terms that both have x. Now, it doesn't matter which one goes where, 6 or 7. And they're both positive in this case, so that's good. Now, if they weren't, it's a good chance, say this was a negative 42, then one of them would be negative, and you'd have to make sure that that one stays negative. But it doesn't matter which one's listed first and which one's listed second. It works both ways, but it is helpful to remember what's going to happen next is they're going to get grouped with these. So which number would I rather 21 be grouped with, 6 or 7? And the answer is 7, because I'm going to factor. And 7 and 21 have a common factor of 7. So it's going to be a little bit easier than working with 6 and 21, 2 and 7. So I'm going to choose to put the 6 first. This way it's paired with a 2. And the 7 second. This way it's paired with the 21. So now I've got 4 terms. So that the AC part is done. Now we have what's called grouping. Anytime we have 4 terms, we can cut it in half, factor the left side. Now this is still set equal to 0, so don't forget to keep that up. I could take out a 2x from this side. I'm left with an x plus 3. So it's just what do they have in common? They both have a 2 in common. They both have an x. They'll always at least have an x on this side. Over here, they won't have an x in common, at least if it's just an x squared GCF kind of thing. But 7x plus 21 does have a common factor of 7. And so I take out 7, and I'm left with x plus 3. And the beautiful thing about AC factoring, when we can do it, is it works because both sides factor to a common binomial, in this case x plus 3. And that's going to be one of our final factors, is that x plus 3. The other is a combination of the GCFs. And what's actually going to happen here, a lot of times we don't think about it this way, is I'm going to GCF this. If I take x plus 3 away, if I take x plus 3 away from the left, I'm left with 2x. And if I take it away from the right, I'm left with plus 7. But a lot of times we just say, all right, the common factor listed once, and then the two GCFs, what you took from the left, what you took from the right, combine those, set it equal to 0. And now we just solve this, and you set each of them equal to that 0, so x plus 3 equals 0. Solve for x, x equals negative 3. And 2x plus 7 equals 0. I got to first subtract 7 to negative 7, and then I can divide 2. So x equals negative 7 over 2. So I see a negative 3 and a negative 7 over 2. which is choice 4. So this is number 1, state sample questions for Algebra 2 trig. It's a long problem for sure, which most of these questions are going to be. Get ready. I think this Regents is going to be a tough one. These questions are super, super important because they're not giving us a practice test. They're just giving us a couple of random sample questions. So we want to make sure we really understand these. But this has this is really 2 topics combined. How to clear denominators and multiply out and distribute and properly do algebra techniques. And then also how to factor an AC factorable trinomial like this. Sometimes these aren't factorable. In that case, we would use the quadratic formula or do completing the square process. But I knew it was factorable based on the answers here. We're not radicals. There's nothing with I and imaginary and stuff like that, so I don't need to worry about those. But we will see that at some point. So this is Algebra 2, State Sample Question 1.